Okay. Welcome in, y'all. Today I would like you to start off with item number 1. That's really the only part of today's warm-up that I expect you to do completely on your own. Start here with matrix A, and then use the procedure that I outlined at the end of lecture yesterday in order to find A inverse. Now, you already know the answer to this question, right? What is the answer to this question? What is the inverse of this matrix, matrix A?
-9, -5, 2, 1.
And how do you know that?
We did it yesterday.
Right, so this is the matrix from the notes yesterday where we already knew what its inverse was. And so what I'm asking you to do is you take the matrix that you are trying to invert, and we are going to stitch it to another matrix, right? We're going to take it and we're basically going to duct tape it to the identity matrix. And what you are going to do is basically the same thing that you would do if you were trying to solve this like it was a regular old linear system, if you were going to do Gaussian elimination. So do Gaussian elimination, but when you do this for a regular old system of equations, on the right-hand side, there are only 2 digits to keep track of. In this case, you're going to do Gaussian elimination to turn this left-hand side here into the identity matrix, but you are going to keep track of the changes over here on the right side, not with just 1 column of numbers, but with 2. So eliminate this -2, eliminate this 5, and once this side has become the identity matrix, you will see that this thing on the right-hand side gives you back the same inverse that we got yesterday. Over here on the right, we're going to do the same thing. We're going to invert this 3 by 3, and then we're going to show that the 2 matrices are inverted. I actually, and listen closely to this part, don't do this one yet on your own. All that you should do right here, right now, is write it as an augmented matrix. So you should have a 3 by 3 attached to an identity matrix that's also a 3 by 3. And then I will do that one for you because there is one row operation that I neglected to mention. You can absolutely take a row and multiply it by a number. You can also take a row and add it to another row. Both of those are valid row operations. But there is one more row operation that I omitted because I think when you start out working with matrices, it's kind of a distraction. But it's important to notice that you are allowed to swap rows. So swapping 2 rows is also a valid matrix operation. And in the case of question 2, it will make our approach towards a solution for the inverse way faster. And then once we're done with the second one, we'll show that these 2 matrices are in fact inverses by matrix multiplication, which, as y'all know from the homework last section, multiplying a 3 by 3 with a 3 by 3 is not trivial, but it's an important exercise to do, and it's definitely an important exercise to see. Take a few minutes on that first part of that first question, and then we'll get going. And then we'll have the rest of the period today, whatever's left of it after this particularly long warm-up, to work on the homework. Tomorrow when we come in, we'll have the last section of notes for the chapter. Tomorrow we will talk about a devastatingly important idea in mathematics. Tomorrow we will talk all about the determinant of a matrix. It is a way that you can characterize a matrix. It's a way that you can learn a matrix or learn something about a matrix that takes all of the digits in the matrix and condenses them all into a single digit. What that digit is highly characteristic of how that matrix behaves. How's it going out there?
It's all right.
Mr. Robinson?
Yep.
For the first question, why are you putting 1001? by the matrix?
Because that is how we find an inverse. It was the last item of notes yesterday.
Okay.
The thing that we are doing is, if you want to find the inverse of a matrix, if it's not just handed to you the way that I did in the notes, you take that matrix, you attach it to the identity matrix, and you do a series of row operations. Basically what you're doing is you're saying that this matrix right here is giving me an instruction for the point x, y, right? This is saying that if you want to get whatever this whole statement is equal to, you take x, you multiply it by 1, you take y, you multiply it by 5, and that gives you a constant on the right. Here, this is saying multiply x by -2, multiply y by -9, and on the right, that gives you a constant. So what you're doing when you do the row operations that turn this into an identity matrix is you are basically inventing the reverse of those instructions. And all of those reversals of the instructions included in this matrix here will then be trapped on the right-hand side. It's an extremely meta way of thinking about it. That's like the way that mathematicians think about what we're doing. I understand that for most of y'all, until you have a few years of doing this, it's just going to be a slew of numbers. But the understanding of this stuff, honestly, like matrix, I don't want to call what we're doing matrix mechanics. Matrix mechanics is what you get when you take a matrix and you start doing calculus stuff to it. But honestly, this stuff is really, really hard to conceptualize until you do a bunch of practice and then afterwards think about what I said again. Oh yeah, and I don't know if y'all also choose to saturate yourself in news yet, if you're that age, if you're still like sitting at home attempting to ignore the world. I don't know if y'all saw, but Los Angeles County is one of the few counties in the entire country that has mass COVID-19 testing available. You have to go onto the County of Los Angeles website in order to register for it. And of course, it's only going out and being made available to people in high-risk professions first. But if you have a part-time job where you find yourself going out a lot, or your parents are still physically going to and from work, they might be eligible to register for initial testing. And the testing centers that they're setting up are drive-up, so you don't have to risk contamination by going into a building or whatever. Like literally somebody in a suit comes out and swabs your mouth while you're in your car, and then they get back to you later. If you just Google COVID-19 testing Los Angeles County, of course, it'll come up. But I saw that yesterday and thought it was interesting.
Mr. Robinson, how long does testing take to get the results back?
I have no idea what method they're using, but there are 4 or 5 different tests that are available, and depending on the tests that they're using, different tests take different amount of time to return. Let me see if yeah, I don't think they outline what kind of testing they're doing. It's probably antibody testing. But yeah, they're making it available first to the elderly and to people who have symptoms, like if people are sick. But Los Angeles does or is trying to make drive-up testing sites available. Anyway, let's go ahead and get started. So item number 1, we're going to use a series of row operations here in order to turn the left-hand side of this matrix into the identity matrix. And when we are done with that, we will find that the right-hand side has become the inverse matrix that we were given yesterday, right? So the first thing that we want to do, and just in general, our target here is to eliminate the bottom left corner and the top right corner of this matrix, right? And the point in doing that, or I guess the outcome, is going to make it so that it matches the identity matrix, right? Because this guy has a 0 here and here. And then once we have zeroed out this corner and this corner, right? Whatever number this is, we'll just divide that row by that number, divide that row by that number, and it'll turn it into 1, 0, 0, 1. So the first thing that I want to do is I want to eliminate these x's. And so I'm going to multiply the first row by 2 so that they are equal and opposite. So that's going to give me 2, 10, 2, 0, negative 2, negative 9, 0, and 1. And now to row 2, I will add row 1. And in doing so, row 1 will be untouched. 2, 10, 2, 0. So it's going to be 2 plus 2 gives me 0. 10 plus negative 9 gives me 1. And here's what's different on the right-hand side. Normally, when it comes to solving a system of linear equations by Gaussian elimination, here on the right, we're only tracking one column. The thing that lets us solve for the inverse is the fact that we are now tracking an entire matrix. So 2 plus 0 will give us 2. 0 plus 1 will give us 1. What's the next digit that has to be eliminated?
10.
Up next, we're going to target 10. And the reason why I highlighted is the fact that eliminating that value actually takes 2 steps, multiplication and addition. I just want y'all to have a way of visualizing how it is I'm, strategizing 2 turns in advance. So the top row is unaffected, 2, 10, 2, 0. Multiply the second row by negative 10, 0, negative 10, negative 20, negative 10. And now to row 1, I will add row 2, which will put us 1 step away from the final answer. And so that gives me 0 plus 2 is 2. Negative 10 plus 10 is 0. That was the point. Negative 20 plus 2 is negative 18. And negative 10 plus 0 is negative 10. Bottom row is unaffected, 0, negative 10, negative 20, negative 10. And now the last thing that we have to do is turn this into the identity matrix. So what do I need to multiply row 1 by?
Half.
Multiply row 1 by 1/2. What do I need to multiply row 2 by?
Negative 1/10.
Negative 1/10. And so the left-hand side becomes the identity matrix. 2 divided by 2 is 1, 0. And then on the right-hand side, dividing by 2 will carry across, giving me negative 9, negative 5. And then down here, multiplying by negative 1/10, 0 is still 0. Negative 1/10 times negative 10 is 1. That's how we know we did this right. The left-hand side is now the identity matrix. And right here, negative 1/10 multiplied by negative 20, that's just 2. And this is just 1. And notice yesterday, we had already tested this matrix, right, to see whether or not it had the correct properties of the inverse. This matrix multiplied by our original matrix A gives us back the inverse matrix, but this is actually the procedure that lets you invent the inverse of a matrix. Are there any questions here on item number 1? Any questions out there? No?
Looks good.
Okay. And now we're also going to do this for item number 2. And this is going to be a bit more involved of a procedure. And in the end, we're also going to test it by 1 step of multiplication. And then y'all will have the rest of the period to work on the current homework assignment. Okay. The first thing that we need to do is we need to take this system of linear equations and we need to turn it into a properly augmented matrix. Oh, I'm crazy. I'm so sorry. It shouldn't. I apologize. I was kind of on autopilot and I wrote all of this as if it was just y equals 2. This shouldn't be y equals 2. It should just be the terms on the right-hand side alone. My apologies. If any of y'all were confused by that, I'm not surprised. So over here on the right-hand side, what are my constants if I were to turn this into a matrix? Hey, I'm sorry, y'all. Give me 1 second. I'm getting a call from my vet. Hey, sorry about that. I get to pick up my cat at 2. Yay. What were we doing? Sorry, I got caught up with the cat. No, really, what are we doing? Oh, right, item number 2, we were gonna invert this system of equations, yeah? So what we're gonna do here is we're gonna start off by setting up our general procedure. And we are going to turn this into an augmented matrix. So what are my coefficients? Row 1.
2, -1.
Row 2.
-2, 0, 1. And 1, -1, 0.
Okay, thank you. And if we are going to turn this guy into an augmented matrix, then on the right-hand side, we need to stitch this to an identity matrix. And again, what we are going to do here is we are going to do row operations up until the left-hand side has become the identity matrix. And when we're done with that, the right-hand side will have become the inverse of this system. Now, here's why I asked y'all to hold off on starting this one up. We could totally start off with just our general procedure that approaches elimination. And we could eliminate these 3 values, turn them into zeros, eliminate these 3 values, turn them into zeros, and then the right-hand side here will become the identity matrix. Now, the reason why I asked you to hold off is the fact that, well, the other valid row operation on top of multiplying a row by a number and adding one row to another row is that swapping 2 rows within a matrix is also a valid operation. So if I were to take row 2 and swap it with row 3, that would be okay to do. And it wouldn't change any of the mathematical properties of the matrix whatsoever. And the reason why we might consider doing that is the fact that this value here is already 0, right? So by moving it up, it will already give us a 0 in one of our desired corners. And this is a 0, and by moving it down, it would also give us a 0 in one of our desired values. Actually, now that I think about this, maybe 3 or 4 moves from now, it won't matter. But let's go ahead and start off with that as our first step. Or would you rather me not, so that we can just work on it the way that we have been? Does anybody have a strong opinion?
Doesn't matter.
Yeah, it literally doesn't matter, because on the right-hand side, we end up with the same answer anyway. You know what, I'll omit it just because I don't want people to be confused about why we're not starting with the identity matrix on the right. We'll just start from here and we'll do this elimination like normal. So I'm going to multiply row 1 by 2, and I'm going to multiply row 3 by -2. We'll talk more about row swapping next section. That's how I'll make up for it. Row 1 multiplied by 2 is going to become 2, 4, negative 2. 2, 0, 0. Row 2 is negative 2, 0, 1, 0, 1, 0. Not doing anything there. And then row 2 is going, or sorry, row 3 is now going to become negative 2, 2, 0, 0, 0, negative 2. And what was the point in that? Why would I multiply the way I did?
To get to REF.
Yep, we're trying to get to reduced row echelon form. So here on the left-hand side, I've lined up these X's to eliminate. So to row 2 and 3, I will add row 1, I will add row 1. Top row unaffected, 2, 4, negative 2, 2, 0, 0. Row 2, we're just going and we're adding these values up. So this is going to become 0, 4, negative 1, 2, 1, 0. And then adding row 1 to row 3 is going to give us 0, 6, negative 2, 2, 0, negative 2. And so I've done right by eliminating these X values, yeah? What do y'all think I should eliminate next?
The 6 in the last row.
Yeah, up next I need to delete that 6. So we're going to try and line up our Y values so that we can eliminate them. And I could try and come up with a smaller common factor. I could multiply this by 3/2 or multiply this by 2/3 to turn both of them into 4, both of them into 6. But that would give me fractions here off to the right. So we'll just increase the numbers. I'll multiply this by 6 so that we're working with 24. I'll multiply this bottom row by negative 4 so that we're working with negative 24 down there in the bottom row. And I'm going to go ahead and do that and also take us to the next page. Yes?
Can you multiply the same row as many times as you need to eliminate the numbers?
Yeah, and
Okay.
it's important to understand these as like features of a matrix. So multiplying a row by a number, adding one row to a number, and swapping rows, no matter what, if you don't make a mistake or whatever, that will never change the solution to a matrix. So matrices have set solutions, right? Like 3 planes intersect at a point in space. And due to the properties of mathematics, which, you know, you'll learn about that stuff if you end up majoring in math and taking number theory, for whatever reason, those particular operations will not change where the planes intersect.
Okay, thank you.
Okay, so it's 2, 4, negative 2, 2, 0, 0. And then when I multiply my next 2 rows by 6 and negative 4 respectively, we're going to get 0, 24, negative 6, 12, 6, 0. And we multiply that bottom row by negative 4, that's going to give us 0, negative 24, positive 8, negative 8, 0, positive 8. Please double check that. Okay.
Yeah, that's right.
Tight. Now to row 3, we will add row 2. 2, 4, negative 2, 2, 0, 0, d, 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 d. 0, 24, negative 6, 12, 6, 0. Add row 2 to row 3, 0, 0, 2. 12 plus 8 is 4. 6 plus 0 is 6. 0 plus 8 is 8. So that's more or less a cleaned up bottom row, yeah? And now I can be efficient in my maneuvering. Now up next, let's go ahead and eliminate these Z's, yeah? I can get rid of those pretty easily in a step or two. So what's a good way that I can line up all of these Z values?
Multiply by 1/3.
Oh yeah, you know what? I like that. I was going to turn both of these rows into 6. That's way more efficient, huh? Because all of these are divisible by 3. So we're going to multiply that middle row by positive 1/3. 2, 4, negative
Wait, Mr.
2.
Robinson, positive or negative?
Positive.
Oh, okay.
And then it's going to give me 0, 8, -2, 4, 3, 0. Oh. Nah, 6 divided by 3, that's actually 2, huh? And then down below, it's going to give me 0, 0, 2, 4, 6, 8. And check it out, these two z values can now be eliminated by this one. So to row 2 and 1, I will add row 3. And then we'll be a few steps from the finish of this problem here. And so when I do that, it's going to give me back. And notice both of these are zeros, so it's not going to change the values here at all, right? It'll be 0 plus 2, 0 plus 4, but this gets eliminated. And then to keep track of those changes, we'll have to add all of these up here, right? So it's going to be 4 plus 2, which will give me back 6. 6 plus 0 for 6. 8 plus 0 for 8. And then second row, same thing, 0 plus 0 is 0, 0 plus 8 is 8, but 2 plus -2, that gives us a 0. 4 plus 4 is 8, 6 plus 2 is 8, 8 plus 0 is 8. And then our bottom row is unaffected, 0, 0, 2, 4, 6, 8. And now what's the final digit that we need to eliminate?
4.
We need to get rid of that 4. So I'm going to take row 1 and I'm going to multiply it by -2. And this is going to give us 2. Oh, no, it's not. It's a bad look. Mistake in the first digit. -4, -8, 0, -12, -12, -16, 0, 8, 0, 8, 8, 8, 0, 0, 2, 4, 6, 8. That was only as fast as it was because I wasn't doing any math, right? I was just copying the line before, which honestly, this stuff will take a bunch of pages to do for your homework, but the math we're doing is not that hard, right? We're just multiplying by digits, adding and subtracting sets of numbers. I'm sorry that it is so time consuming. There's really not a better way to represent this. Nonetheless, we add to row 1, row 2. And then we'll be one step from the end here. So this is going to give us 0 plus -4, still -4. 8 plus -8, 0, 0, and now we need to figure out what this does to the right-hand side. So it's going to be 8 plus -12 for -4, 8 plus -12 for -4, 8 plus -16 for -8. And then the rest of the matrix is the same as it was before. We could just copy that down. 0, 0, 8, 0, 0, 2, 8, 8, 8, 4, 6, 8. Final step, we need to make the left-hand side identity. So how do we do that?
1/4, 1/8, 1/2.
Multiply this by -1/4, multiply this by 1/8, multiply this by 1/2, so that instead of this being a diagonal matrix with funky values, it'll be a diagonal matrix where all of the entries are 1. And so I'm going to take this final step to yet another page, just because we have a step of verification, and then down below I'm going to make some extra notes. Sorry. This will make it 1, 0, 0, 0, 1, 0, 0, 0, 1. That was our goal. And now on the right hand side, -1. Oh gosh, dang. So many digits to track. Don't do math in pen. 1, 1, 2, 1, 1, 1. And 2, 3, 4. So that's weird. Somebody is attempting to join the class who is not in the class. Does that mean one of y'all gave the password and add code to the class out? Because in my other classes where that's happened, it's meant bad things for everybody's participation. Hope I don't find you. Nonetheless, if our original matrix was that first set of digits, so let's say that it was called some matrix B, our original matrix in that first step was 1, 2, -1, -2, 0, 1, 1, -1, 0. Then B inverse is what we end up with on the right-hand side of this matrix here after all of those row operations. B inverse is 1, 1, 2, 1, 1, 1, 2, 3, 4. Are there any questions on the work that we did in order to construct the inverse of matrix B? I know it's a lot of individual steps, but is the logic okay? How we set it up and what work we do to get there.
Are we gonna have to check our work after during the test?
Yeah, but that means that for this step, you have to do 2 entire sets of 3 by 3 matrix multiplication, which, considering producing one of those columns, involves taking 3 digits and 3 digits, multiplying them and adding them, and you have to do that for 9 entries. It actually becomes 27 operations per check, and you have to do 2 checks, which would be 54 operations to guarantee that this is true. When it comes to the actual test, when I have you construct an unknown inverse and then verify it, I guarantee it'll be a 2 by 2. Otherwise, I would have to give you 3 hours for this test, and you could like throw on the Lord of the Rings in the background while you do it. I don't want to give or grade a 3-hour test, y'all. And so in order to verify this, we're actually going to use our calculators. So go ahead and bust out your TI-84s. And on top of that, and on top of taking out your TI-84s, we're going to use it to check this. Also, I probably shouldn't tell you this, but I'm going to anyway. Your calculator can take an inverse. Calculators can invert matrices, and straight up, this is not a thing I learned until like last year, and I was pretty upset when I learned it. So the first thing that we're going to do with our calculator is we are going to verify that these 2 things are actually inverses. And what's the test for that? How do I check to make sure that these 2 matrices are inverses of each other?
You multiply them by each other and see if you get the identity matrix.
Spot on. So that is to say that B inverse is equal to the identity matrix, and B inverse B is also equal to the identity matrix. The reason why we have to check it both ways is the simple fact that matrix multiplication is not commutative, right? So this means that A times B will not necessarily give you back B times A. Technically, you do need to check it both ways. And so, did y'all get a chance to get your calculators?
Yeah.
If not, bust it out. And of course, this video will go up on YouTube in case you ever want to check this tutorial. What I'm going to do is I'm going to hit second. I'm going to hit matrix. I'm going to edit 2 matrices to match B and B inverse. So I'm going to edit my first position here, matrix A, and I'm going to give that the original matrix. I wish I could use the number pad. And this is going to give me, let's see, 1, 2, -1, -2, 0, 1, 1, -1, 0. I realize when I talk about these like steps of matrix math, it sounds like I'm chanting a spell, like made of math. Anyway, now that I've inputted matrix A, I'm going to quit back out, clear that. Then I'm going to hit second matrix, and I'm going to edit in our inverse that we invented into matrix B's position. So I'm going to enter in here a 3 by 3. And by the way, when I click around, can y'all see the mouse pointer move so you know which buttons I'm hitting? Or does that not show the mouse pointer?
No, it does. It shows.
Okay, tight, perfect. 1, 1, 2, 1, 1, 1, 2, 3, 4. And then again, I'll quit out. And by the way, here's another tip I want to give y'all that I think I neglected to mention when we were doing the first calculator matrix tutorials. If you want to check to make sure that a matrix has been entered correctly, you can actually just call it alone. So if you input on your main screen, hey, just hit matrix, matrix A, and then hit enter, it'll call all the values. So right now, I'm just going to call matrix B just to show that all of the values are entered correctly. So now to see whether or not these are inverses of each other, I'm just going to multiply them. And it's just like, you know, putting things in parentheses side by side. All you have to do is put them side by side. So matrix A times matrix B, enter. Oh, look, it's the identity matrix. And then we should also get the same thing if we do this reversed. Second matrix B times second matrix A. That also returns back to us the identity matrix. Is this okay?
Mr. Robinson, how do you clear it again?
Clear what?
Like the data you inputted for each matrix.
So that's annoying. It's under the memory menu. You'd have to hit second memory, option 2, memory management, and delete, and then go down here to option 5, where you can choose which matrices to delete. To be honest with you, I almost never do that on my own calculator. It's a lot easier to just go to the matrix menu and just edit over the last matrix that was there. So if you just change the size to 3 by 3 and edit all of the values to be the values of the new matrix, it's like the old one was never there in the first place.
Can I change the size of the matrix, like from 3 by 3 to 3 by 2?
Yeah, and if you make it smaller, it'll automatically delete all of the values that were in the furthest out rows. And if you make it bigger, the new rows that it adds are automatically zeroed out.
All right, thanks.
Okay, so now this last part, the part that you probably want to know, and in the end, I will write this down on the whiteboard in notes so that you can get it down. Yo, this thing will take an inverse for you, which made me really upset when I learned it, because when I was learning to do this stuff, I learned to do this stuff really late, like when I was in college. So I was literally teaching it to myself, and this was before Khan Academy. Oh God, I just dated myself. It was before Khan Academy, children, which means that like you would go on YouTube and you would type in like, how do I invert a matrix? And all the videos would be garbage potato quality like this. I was really upset when I found out that a calculator can do this in a single step. Here's all you do. You literally just use the representations that are in the nomenclature. Now, that is to say that when I write B inverse, I'm just writing down B to the -1. Your calculator knows that. So if I want to invert matrix A using the calculator, all I have to tell it is, hey, what is matrix A, right? Second in, second quit. You don't hit second, you just hit this button again to the -1. And when I do that, it just takes the inverse in one step. Your calculator can do all of those row operations, that 3 pages of math, in less than 1/100th of a second. So yeah, you just.
So Mr. Robinson, why can't we just do it that way?
Because the point is to understand how to do it by hand. And of course, come the test, if you don't put all of the work, all of the steps, you get none of the credit.
No, I'm thinking like college or stuff, when we need it to be like a 2-second thing, we could like, doesn't it make sense to use this?
Oh yeah, no, absolutely, yeah. And that's why I am showing you that a calculator can do this anyway, because you will hit a point in these problems, sorry, not in math, but like in your future engineering or physics courses, where getting the inverse of a matrix is actually just one step in a much, much larger procedure. And if you just need the answer and you don't need to show the work, yeah, go straight to a calculating device. Like whenever I'm calculating anything, I almost always use a computer, because like I know how these operations work. I know how to input them in a computer, and I need to do it quickly and precisely. You only learn these methods by hand so that you know what the calculator is doing in the background to invent the correct answer.
Okay.
Yeah. Anyways, let's go back to the whiteboard. So yeah, calculators can invert matrices, and it's a simple step. You just put in the matrix, and then you raise it to the -1, And this produces the inverse matrix. Like your calculator knows how to do this. That's actually so straightforward. I don't even need to write the steps. You all know which buttons to push. Are there any questions on this stuff? That's about it for inverses.
Mr. Robinson,
Yes.
to verify, you would have to do both multiply the original by the inverse and then multiply the inverse by the original.
Yeah, and I'm going to be a little pedantic for a second. With a 2x2, that's actually overkill. It's impossible to invent a scenario where A times B would give the identity matrix, but swapping the positions doesn't do the same thing. You have to be careful with 3x3s because I can give you two matrices where multiplying the first one by the second one will give the identity matrix. But if you swap it, multiplying the second by the first one doesn't give the identity matrix.
Okay.
Does that make sense?
Yeah.
Okay. Have I ever like yelled at y'all about how you would teach kids to use a graphing calculator, but when I was in high school? Have I shown you the like nightmare that was the old way of teaching kids to use a TI-84? Because as I show y'all how to do this stuff, you gotta admit, like, it's pretty complicated using a graphing calculator. It has its own like weird internal language that you have to know. And back when I was in pre-cal and calculus, I had teachers who were like, hey, it's really important. The way that you used to show kids how to use a graphing calculator sucked because they couldn't show you the buttons. Like that mouse pointer shows you the buttons, which I think is probably the best part about doing lecture this way. And even when I'm in class and I pull up that same like emulator on the smartboard, it's tight because I can show you the buttons. Back in the day, you'd have to use one of these boys. Do y'all see my like browser screen?
Jesus.
Yeah, and it's a giant Game Boy screen, basically. It's a transparent Game Boy screen that you plug into a teacher's version of a graphing calculator, which of course is more expensive even than a regular old graphing calculator. And then that would use an overhead projector that you would put underneath it, and it would project it up on the wall, so you could only see the screen. So on top of the picture being like crappy because it's coming off of an overhead projector, you would also need to listen to the teacher very closely as they were like, I'm pressing second, and then x to the -1 to get matrix, and then da-da-da-da-da-da. And even after just a few buttons, boy, it is a lot more difficult to try and understand what somebody's doing with a TI-84 when you can't see their hand moving across the screen. Anyway, this time is yours. We have about 10-15 minutes. If there are any questions on the homework, I can address those now. But I believe I made the homework due tomorrow. I don't think this stuff is hard. I just think it's time consuming, and I wanted you to have a little bit of extra time so that you could, you know, do a good job.
Mr. Robinson,
Yeah.
can you quickly go over how to find the inverse on a calculator? My Zoom was lagging. I couldn't hear anything. It's working fine now. Just like really quickly.
Totally, yeah. And I will. Give me 1 second just because I'm punching in the attendance, just because I forgot to do that, and then I'll switch over to the calculator. And then also, of course, keep in mind that this will go up on YouTube afterwards.
All right. Okay.
But no, I'll do it again. Yeah. It's literally one step.
Okay.
Oh, also, I guess I'm going to do an advertisement real quick. It's not a paid advertisement. It's an endorsement. Video games are really hard to find right now. just because, you know, everybody's stuck at home, and so they're like, oh, I should get back into video games if I haven't been into it this whole time or whatever. So it's suddenly become really hard to find Nintendo Switches and certain versions of consoles and specific releases of games. I believe deeply in supporting local business, especially in these difficult times, and I am not financially invested in the place I'm about to call out. I just think they do a great job. There is a video game store in Burbank on Victory Boulevard that has special permission to open 2 hours a week. They're open for 2 hours on Saturday afternoon from 2:30 to 4:30. So you can like pick up new releases. They also have old video games in the back of the shop all the way back to the NES era that you can also shop through. It's one person in the store at a time. And they have a really hardcore cleaning regimen. So all of the employees wear masks, and whenever they buy old video games for intake, they sanitize the entire outsides of them and then leave them in a box with UV light to make sure that they are completely sanitary, you know? If there is a specific video game or device or console that you are looking for that you haven't been able to find, I would email them. It's Game Realms in Burbank. They do good work. Try and support your local businesses in any way you can. How to take the inverse of a matrix. So your calculator, I'm sharing the calculator screen, right?
Right, yeah.
Okay, so you just go to second matrix, and here's matrix A real quick. It has the values 1, 2, -1, 2, 0, 1, 1, -1, 0. All that you do to take the inverse is use the same symbolism that I wrote on the page. So if you want A inverse, it's literally A to the -1. You just press that button again, and when you hit enter, it automatically generates the inverse.
Oh, okay, I see.
Yeah, and yeah, interestingly, these types of row operations of matrices are actually what a computer is always doing, which is why that thing that just took us like 15 minutes to do on paper and dozens of steps, even your graphing calculator, which by computer standards is weak, right? It is also capable of doing all of those calculations in almost no time. And that's just kind of like how the architecture of computers is. But when you send a text message, every step of computation that your cell phone and the receiving cell phone is doing, it's all a series of weird matrix row operations. It's just that the matrix that is your text message is probably like thousands of entries by thousands of entries. And even then, it is capable of doing those operations so quick that it's zero time to us. Weird question. What does the screen look like when I'm on the graphing calculator? Does it center it in the middle, or does it stretch it?
Just looks normal, center.
Yeah, it looks normal.
Oh, it just centers it and makes it the full
Yeah.
height of the screen?
Yeah.
Okay, that's cool. I do rewatch little bits of the videos that I put up on YouTube just so that I can like edit out any like dead time if I'm just having y'all work or whatever. But I've never looked at what the screen looks like on the calculator. Mm. Man, I'm so excited to go get my cat back. He's gonna be so sad. It's always funny when they come back from the vet and they have that little spot that's shaved, you know? Have y'all ever seen a shaved cat?
No.
Oh, yeah, it's so sad. Oh, you have?
Yeah.
If a cat has a pattern when they shave the cat to like do surgery or whatever, the skin underneath the hair has the same color as the fur, which I think is
No
really
way.
weird. Yeah, so my cat is like brown and white, and when they shave his paw to do anesthesia or whatever, you can see the brown part and the white part still. And then after I get him home, I get to go through the fun procedure of filing an insurance claim. Yay. The best part about being an adult is the never-ending paperwork. We have like 4 minutes left. How are y'all doing with college stuff and high school stuff for next year, like making the transfer, making the application? Do y'all have any questions or have any like big thingums that you want me to talk about? No, y'all are good?
Okay, I guess we're still waiting for news.
What
But-
kind of news?
But like for the exit exam, for example, for now we're taking it in June, I think, or July, but that's all we know. They haven't canceled it or anything.
Oh yeah, so I talked about it yesterday, but I'm gonna yell it at y'all one more time, just because I know that some of y'all were already registered to take one of the upcoming SATs that was canceled. If you have an SAT that was canceled, you'll be given first priority, so you'll be able to enroll for that first week SAT as soon as they reopen it. Which I don't know if that's like good or bad. Like if I was you, I wouldn't want to go to the first week back because that seems like it has a chance of that seems ill-informed epidemiologically. I'll leave it at that. But if you had a test canceled, you can go back and take the first test as soon as they open. But also, like all of the colleges say they don't need your SAT score.
Mr.
So-
Thompson, I'm talking about a exit exam.
Oh, I'm
Chess
sorry.
beat.
Oh.
Yeah,
Huh.
to go to PCC.
Oh, word. That is rough. Have any of y'all tried reaching out to PCC's admissions and asking them if like what the deal is with that?
I emailed
Maybe
them.
we should. Yeah.
I emailed them last week. They haven't responded.
As soon as you get that response back, can you forward me that email chain?
But I didn't email about Chesby though.
Can somebody email the counseling department at PCC,
Yeah, I'll probably
ask,
do
and
it.
then yeah. Once you hear back, let everybody know. That's a really good thing to figure out.
So
Yeah.
I had signed up too originally, but I called for a refund. I never got a call back.
I bet
Yeah,
it's
they're very
because
unresponsive.
I bet it's because their offices are physically closed, and like we use Gmail, so I can log on to my work stuff from anywhere. I'd be willing to bet that their counseling system is closed loop, like not on the internet. So I bet there's a bunch of messages they don't have access to from home. But hey, y'all, it's the end of class. I actually think we blew past it by a couple minutes. Y'all have a very nice Tuesday, and I'll see you tomorrow after I get my cat boy. Peace, y'all.
See you tomorrow.
See you, Mr. Robinson.
Uh,